Okay, hello. We are going to pick up where we left off with the perilymph and endolymph. And what I want, okay, and um, what I want to start with is what's going on here and, of course, in the semicircular canals. So, a few things. First of all, I don't know. Hold up a sec. Okay, here we go. Now I got a pen that works. So we have two senses of equilibrium. One of them is static equilibrium. And again, if you want to put this on a different piece of paper, because we have some different drawings that we want to do, you have static equilibrium, and then we have something called dynamic equilibrium. Static equilibrium is talking about with your head, the position of your head, pretty much. When your head is still, has to deal with posture. When your head and body are still, not in motion. And obviously dynamic, this is when you are in motion, which is what your semicircular canals are. So what you have, the static equilibrium, is actually taking place right in this area. And you have two, this is called the vestibule. And the vestibule is made up of two parts called the utricle and the saccule, which are these two parts down here. You can see F and G. F would be the lower one, the utricle, and the saccule is the utricle is G, which is higher up, so up, and the saccule is F. So it's in this base area here. And what you have, it is very similar to what we were talking about before, but you have, in this area, you have a membrane, and you have this gelatinous material. So what you have is you've got this membrane, and you have these hair cells. Okay, here's the hair coming out. Here's the cells. There's the nuclei. Okay, and they extend into like this gelatinous material. And in this gelatinous material, there are these little rocks. And they call these rocks, great name, otoliths. These are bits of calcium. And whenever these otoliths move, so your head moves, these will pull one way or another and pull this gelatinous material down, which again bends hair, or the cilia. And that bending, of course, that deformation, this all then goes into, a nerve fiber and everything when those hairs move. And that's because these otoliths move. Let me see if I can get you. I have a picture. I was going to see if they showed. I want dynamic equal. So let me see. I'm looking for a classic, my favorite picture right here. This is actually right from your textbook. See if this will blow up a little bit. Here it is right here. So let me show right here. So here's so a couple parts that I want to point out. So here you have the macula, which you do need. So here's your hair fibers. The macula, which is part of the cells and the gelatinous material, and here's the otoliths. Okay, so make sure that when you look at that you have that labeled on your sheet that we just did. So there's that picture of what that looks like. That's actually right from your textbook. So you can see with the head bent forward where these otoliths and the gelatinous material sags, and those tend to bend. And we'll come back right to this in a second. Here is dynamic equilibrium, and this is happening in those bases of your semicircular canals. So without doing too much crazy drawing here, to go back There we go. So you can actually point out a couple things that I want to look here. So if I were to draw this, I would draw this part up here. Okay, and here's your nerve fibers. Again, here's cells. And then here's the hair extending up into this gelatinous material called the cupula. That's the cupula. And whenever this cupula, so again, this is down here in your bases, whenever this, and here's your endolymph, which is your fluid to begin with. So this bends, and this will cause the hairs to bend as well. A couple of words. The receptors are called the crista ampullaris. So this whole thing is called the crista ampullaris. Okay, and the swelled area they kind of say is the ampulla, but this is the cupula, which is the material, gelatinous material. Kind of interesting, couple things to keep in mind when you're thinking about this would be those of us that get motion sick. And what makes some of us motion sick more than others, a lot of it is eye coordination too. What your eyes tell you, what's going on, and what your body feels. That's a huge thing. So virtual rides for me, I've been on a virtual pinball before. Terrible pinball machine where it feels like I'm in it, but yet my eyes, I cannot watch. I've gotten sick watching Twister at the movie theater because my eyes are telling me I can't watch Blair Witch Project. Any sort of shaking videography is just terrible for me. Just absolutely terrible. So that does not work at all. So that's some of the things that you need to think about when you think of motion sickness. Is some people can do those rides. I can't. My brain doesn't. I don't know why. I can with drugs if I take lots of Dramamine, but even turning around in a bus is really, really hard for me to do. So that's how your equilibrium for your ear works. So let me go back. I was hoping for, let's see, that was not what I was hoping for. I was hoping for the ear model. Let me see. Ear hearing eval 10 census quiz. I don't think that's, I must not have the 2 sheets with the eyes printed off. Let me see, ear quiz, nope. Census quiz. Let me do one check. Nope. So that was our quiz from yesterday. Okay, so what I'm going to have you do now is go through the eye with my notes, so coloring the different parts of the eye, and the only other thing, I guess, what I can do right here quick is I will, on the screen that has the eye, I want you to do a quick drawing for me on the side, so do your best. Eye here. Okay. Okay, so a couple things. You remember the orbicularis oculi. That closes the eye. Okay, you also have another one called the levator palpebrae superioris. That is another one of my favorites. You know, past the sternocleidomastoid, that's one of my favorites. Okay, these, of course, this opens the eye. Now, as far as accessory organs to the outside, okay, you have your tear gland. Now, this is looking at the outside, so this is the peripheral here. So this would be, we're not going to call it your tear gland. This is called the lacrimal gland. So your tears are produced on this side and then flow across towards, and so let me draw my best nose. Right there. Okay, so that's the lacrimal gland. It produces tears that flow across the eye, and then you have the lacrimal sac that collects, and then you have two little canals here. That is your superior and inferior caniculi. Oops. There. And those flow here into the lacrimal duct. Now, what this equals is, so say I have tears. Oh, I'm crying. Okay, tears, tears, tears. So tears are flowing down here, thrown across. You don't flow it out of the eye, but there's quite a few. Tears are coming down here. So in the middle of your big argument, then your nose starts to run, which is so disgusting. Okay, that's literally what happens. Right now, with Bryson, we have a blockage somewhere in here. I'm not sure why. There's a lot of swelling going on. So what happens is he's got a lot of all those eye gunkies get in here and then come squeeze out right here, which is really gross. But it happens. So he gets like build up right here of, I should color it the right color, there we go, of yellow gunk. And he always has a tear in his eye. So what we're doing is we're massaging this area. What I think what's going to happen is we're going to have to go up with a probe and actually clear out that area because we're not having much luck. It doesn't seem to get any better. Something else to keep in mind, a word that I want you to keep in mind, is something you've heard of. It's called conjunctiva. Conjunctiva. There we go. The conjunctiva is your tissue that lines the eye. And you're probably most familiar with this is because I'm sure you've heard of something called pink eye, which is called conjunctivitis. So when you look at, I'm not sure, I hope I spelled that. I don't know if it's conjunctiva. I'm not going to look it up right now. So you get swelling of the inner eye on the lining of the eye, which can be quite contagious, both bacterial and viral. And that's what they said that Bryce had at first. One other thing, I guess, while you're coloring, so if we have an eyeball here, that wasn't my best eyeball. Your parts of the eyeball with your muscles. So if this is the top, you have a top muscle here. I'm going to draw a nose here. So we're looking at the right eye here. You have the top muscle, which is your superior rectus. You have your, I'm going to draw it back like this, kind of 3D. This is your inferior rectus, which is on the bottom. Then you have on the side your lateral rectus. And then on the inside, your medial rectus. Now, those aren't hard. They're all rectus. You just have to look at your directions. After that, then it gets a little bit more complicated because we've got two that actually go here and actually go here, which attach to the eye as well. So I'm going to let you take off with those. And then what I'd like you to do is try to color as much of the eye as possible, and we'll finish that up tomorrow. I'm also going to have you look at this sheet here, which I'm going to print off because it's more reading, which I think you can do and still understand. So I want you to read this part about rods and cones and take a look at that and the nerve pathways. And then I think probably what we'll do is we'll finish up the eye on Thursday, and then we'll dissect eyes on Thursday. And then we'll review on Friday, test on Monday. Okay, thanks.